Okay, so on Friday, you will recall I introduced you to this idea of equilibrium. And equilibrium occurs when the forces are all equal or balanced, right? You could say that the net force is zero. Okay, and so we worked through that. I gave you a new word to know, the equilibrant. If I asked you what the equilibrant was, you would say that it's the force that produces equilibrium. Right? If you've got two forces pushing or pulling, some other third force would put it into equilibrium. And you learned that the equilibrant is really just the resultant flipped around, right? That's what I told you. It's the resultant flipped around. Okay? And I showed you how you could view it as sort of an idea of vector subtraction. Okay. Then we did an example. Ty and I broke the string. Right? That was fun.
Dangerous.
Was a little dangerous. I had the safety glasses on.
Whoa.
Okay. We did this practice question here, which was virtually the same as the one in the samples. So you got good at that. Then we did this one here, and I think I had to show you how to do vector addition again, right?
No.
And then we went like that, and then that is our equilibrant. And I think if I'm not mistaken, I also did number 3. Am I right?
Yeah.
Okay, I did that one with you, and again, you solved those by vector addition and then flip. And I think I asked you to do this one, right?
Yeah.
Okay, so what you're saying, Danielle, is you'd like me to go through this one.
I got already.
Okay. Okay, let's do that. So we've got two forces exerted on an object. A 36 Newton force acts at southwest and a 48 Newton object acts at southeast. So if it says exactly southwest, that means exactly 45 degrees, and southeast is also exactly 45 degrees. So maybe that helps.
Well, yeah, I didn't know you degrees. Yeah.
Okay. So now that I've given you that, do you want to try it now?
Yeah.
Okay, try that. Good idea.
I already knew that. See?
Okay, so let's draw our picture here first. We got two forces, 36 newtons at southwest. So 36, we'll call this F1, applied force, F1. 48 newtons acts at southeast. Oh, so this is not southwest, is it?
No.
Southwest would be like this, right?
Yeah.
Call that F1, and that would be exactly 45, right? So that's exactly 45, and southeast, well, that's also going to be exactly 45. So that, and this one is 48 newtons, right? Okay, so you can clearly see that the equilibrium is going to be kind of like that, right? Okay, so let's do this by vector subtraction. Let's say F net is equal to F1 plus F2 plus, we'll call it E for equilibrium.
Wait, what?
Right?
I did this wrong.
You might be doing it slightly different. Just sit back, enjoy, watch, and then if you want to copy down, great. Or if you want to print it out later, also good. Now, the F net is going to have to be equal to 0.
Wait, I thought we were...
Okay, now, do I have F1 and F2?
No.
Yeah, it's 36 and 48, right? I'm solving for E. So my E is equal to 0 minus F1 minus F2. There, I've done it by vector subtraction.
I thought you wanted to find components.
Oh, yeah, we'll get there, right? We'll get there. But I've shown the vector subtraction.
Do I need to show
That's
that
it?
testing that?
Well, I mean, that's not it. I still got to do the math, right? But I've set it up,
Oh.
right? Now, let's just say ready, John? Let's just say that these numbers are easy, 5 and 3, and they were in the same direction. I could just write minus 5, minus 3, equilibrium is minus 8, right? If these vectors were 5, I guess that would be smaller, 5 and 3, then the total would be plus 8, which would make the equilibrium minus 8, right? I mean, that's the same theory. But the problem is that they're not 5 and 3, and they're not in the same direction. They are indeed other vectors. Right? Okay? So I would have to actually do the vector subtraction. So is it also, could you also say EX, the X component of the equilibrium, is equal to 0 minus F1X minus F2X? Would that be true? And therefore, EY would be 0 minus F1Y minus F2Y. Right? Can you find those X and Y components? Of course you can. Let's do that. Right? So F1 is going to be like this, 36. And it's down and to the left, right? Right? Let's confirm that. 36 newtons, X southwest, southwest, yeah, okay. So this will be F1Y, and this will be F1X, right?
Yep.
So F1X is going to equal, the F1X is opposite, so that's going to be sine 36 sine 45. What is it, EJ? 25.5. Now, because that's to the left, it's going to be negative.
Okay, I got this. I just don't remember we used the right word.
You might have done it slightly different. That's okay. Sort of different way of doing it. It's okay. There's more than one way to get to Smitty's.
What the heck?
F1Y would be what? 36.
Maybe the same thing.
Oh, and if it's 45, it's going to be the same number. And that's also going to be negative. Why? Because it's down, so that's going to be minus 25.5. Now I should do the same thing for the other one, right? So that's going to be this one here, this 48 southeast. So this is going to be F2X, F2Y. So that's going to be 48 cos 45, right?
Yeah, I just didn't use the fancy F2X. I just put X.
Great.
Would I get marks off of that?
No.
No?
33.9?
Yeah.
Now that's to the right, isn't it? So that's going to be 32.9. And F2Y is going to be down. Hey?
33.
Oh, 33? Okay.
Confusing us.
0.9 though?
Yeah.
Talia, question?
No, I never mind.
Oh,
I figured
okay.
it out. He drew his different.
Oh,
Because I was gonna say, why didn't you go south? Because south comes first, like south.
I should have, yeah.
But it's still what you say.
It's still 45, yeah.
Yeah.
Yeah. You're right, I should have for clarity.
Come on, Mr. Fanning.
Rookie move. Like I only been teaching physics for 27 years. Oh my god, I can't believe I said that.
Not so long.
It is. It's so long. I still think of myself as the new guy.
I thought it was like that before I was born.
Holy crap.
That's okay.
Holy cow.
Yeah.
Still cool.
I like to think I've gotten a bit better at what I'm doing. Okay, so EX is going to be, is this thing right here, right? So it's 0 minus F1X, which is minus 25.5. And then subtract F2X is going to be minus
Wait.
33.9.
Oh.
Because I'm showing, well, I'm showing vector subtraction, Josh, that's all.
So if we didn't put the zero, what would happen?
Darn it.
I mean, here you should show it because you're sort of,
Wait, wouldn't X
like,
be,
you're explaining what you're doing,
wouldn't
right?
X be positive? Or which one's X?
These are both X's. This is F1X and this is F2X.
Okay, but on which, so the first one's X, right?
This is an X, this is an
No,
X.
F2X.
This is F1X, 25.5. This is F2X. Okay, hold on. So 0 minus 25.5 is going to be
Oh, I just fucked it up. No.
25.5. Riley, salty language.
All these flavors.
Minus
I
33.9.
just messed up everything.
Work is important. I'll give you credit for work. So 25.5 minus 33.9 minus 8.4. That's just the X.
It's like a positive 8.
That's just the X component, right? But now you got to do what?
Why?
Because we got it.
Well,
Or you mean you got to do the what? Dawson got it. Thanks, Dawson. So EY is going to be 0 minus... Is it not going to be exactly the same thing? Am I not using the same numbers?
No, it's gonna be.
Oh, it's right, because that's going to be negative, and this one's also negative, isn't it?
mm-hmm.
Oh. So it's really going to be...
You skipped the second. Yeah, you did.
What?
Oh, yeah. Gotcha. Gosh. If only I'd made that mistake on purpose to show you what a common mistake might be.
I made that common mistake.
So that's going to be subtract negative 33.9, right? Okay. So in fact, they're both going to be positive. $59.4. Now, does that make sense that the EY would be up? Did we not, at the very start, did I not say it's going to be kind of up and to the left?
But how did you know that?
Well, look at that. If there's two people pulling like that, right, and this one's a little bit more,
You're gonna have to go that way.
right? Okay, so now what do you do with these components? Isn't this just like the first unit?
You gotta find C. Oh,
It just takes practice. So EX is going to be minus 8.4.
like, oh, EX. Where did
EX.
that come from?
The X component of E,
Yes.
and EY is 59.4.
I just put X and Y again.
Well, it's the X and Y components of E, right? So that is E. Is it a right angle? Absolutely.
So I drew mine.
So E squared is going to be 59.4 squared plus 8.4 squared. Nope. Yeah, you're squaring it. It's just a triangle now. So, oh, I messed that up. I almost said what Riley said. Riley, you're being a bad influence on me.
Rig. What'd I do? Oh, okay.
59.99. Shall we just say 60?
Jump. I got 59.99. So.
For some reason, my X and my Y like switched, but I got the same numbers. So like, would that be like?
It's 45 degrees, so that's not unusual. Where are we taking the laptops there, Jen? Where are we taking the laptops? Okay. Yeah. Just make sure it comes back. Make sure it gets shut down properly. Thank you. So that's going to be 60 newtons. Do we have an angle? We need to find it, right?
It's the angle here. It's
So
like-
inverse 10, opposite over adjacent, 59.4 divided by 8.4.
The only thing I messed up on was the direction.
82 degrees, yep. So that's going to be west 82 north, which is equivalent to north 8 west, which is kind of like I predicted right at the start.
Holy crap.
Now, all I did was show this by vector subtraction. If you were to do this in a non-vector subtraction way, then you would simply, right, you would take these X and Y components, but instead of doing subtraction, you're just adding them together, but then at the end, you're gonna flip it around. That's all, right? So it's virtually the same. It's just about, do you flip it around by putting negatives in here, or do you add them together and then flip it around at the end?
Oh.
Is it not? Mervin has a question.
Just do like 36 square.
Wait, everyone was easy.
36 squared plus 3 squared?
Let's see if I was going by fast.
Well, Mervin has discovered that because it's 45, that this is 90, right? So you could have taken this vector here, moved it there. It would be a right angle, like that. So that would be your resultant, and then your equilibrium would be that one right there.
See,
That's what you're saying,
what I
right?
was gonna do.
That's okay too. There's more than one way to get to smooth.
Oh,
So which do you want to do?
I don't care.
every word.
Doesn't even use the code.
Now, having said that, am I always going to make it nice and easy, like 45 degrees? No, right? So I know that if I did that,
We're probably gonna do.
exactly. So what I probably should do is not make it just like that, right?
If it's
So
not a 45 degree,
then you got to do components.
it still adds up to 90 degrees.
Oh yeah, if it was 30 and 60, you could do that. Sure. Yeah. Now, are there some? Yeah, there are, right?
Wait, could you go back to like the seconds?
I'm going to give you guys some time to work on those practice problems because I really, really want to find that lesson and I don't want to recreate it.
Joe's.